Before I begin, imagine you are a policymaker providing recommendations on whether masks should be mandated in supermarkets. To make this recommendation, you might need to evaluate risk across different regions, and one question you might need to answer is, did Washington have a lower risk of COVID compared to California around April 2021? If you are working with this map, your answer to this question might be yes, because Washington is in a lighter shade of red than California. But your answer might be no if you were working with this one instead. So is the answer yes, or is it no? The visualization you are working with can directly affect your decisions. So let's take a look at what's different between these two. The left map was made with absolute case counts, whereas the map on the right shows cases normalized by population. When the underlying question is risk in each state, it's not useful to design the visualization with absolute case counts because it makes sense for states with a higher population to have a higher count. So it's better to use cases normalized by population when making this map. And the correct answer here is that Washington did not have a lower risk of COVID compared to California around April 2021. But let's examine this map again because it leads to an interesting set of issues. This map was not best suited for answering the risk question because it was missing normalization, which is one example of what we call reasoning misleader, or issues in grammatically correct visualizations that can lead to conclusions not supported by the data. We consider this map to be grammatically correct because just by looking at it, there's nothing wrong. It faithfully conveys the values and relationships in the underlying data with no visual distortions. Grammatically incorrect visualizations would involve distortions such as truncating the y-axis, which you can tell just by looking at the visualization. Missing normalization, though, is not the only issue in this set. We identified 6 relevant issues that we deem reasoning misleaders from prior work, which is driving our overarching question of how can we better guard against these reasoning misleaders. This set of issues are part of our framework, which I will go through in a few slides. We contribute FRAMER, Visualization Framework for Mitigating Reasoning Errors in Public Policy, and we developed it through 3 phases, which also serves as the outline of this talk. But let me first give you an overview of our framework, and then I'll go into the details of the development process. The categories in FRAMER include this set of reasoning misleaders curated from prior work, which you saw before. And there's also a set of data considerations that's relevant to certain sets of reasoning misleaders. For example, data representativeness is mapped to missing data and cherry picking. Comparison basis is mapped to missing normalization and inappropriately aggregating. Distributions is mapped to concealing uncertainty and inadequately representing uncertainty. For each data consideration, there's also one relevant policymaking stage, such as what variable shows the problem size. Is the problem size different for subgroups? And is the problem size worsening and at what speed? The reasoning misleaders, data considerations, and policymaking stages are the 3 core categories that make up our framework. We presented FRAMER on a 1-page format for ease of transfer, and the final framework has a hierarchical structure with the data considerations at the top, each followed by an example policymaking stage, so users can ground it in public policy, and each stage is followed by relevant reasoning misleaders to consider. We also included a table made up of combinations of reasoning misleaders and common chart types to visually demonstrate the effect of these reasoning misleaders. Each combination has a potentially misleading example and a better one for contrast. So this is the final framework we ended up with. I will now briefly go through the development process and talk about how we got to this point. We first constructed a preliminary framework from literature. This early version followed a step-by-step process, starting from the policymaking stages to the data considerations and all the way to the visualization examples table. This has its own development process, which involves literature reviews about visualization issues, work from practitioners like Hans Rosling, and literature from the policymaking space. You can find more details in our paper. But with this preliminary framework, we wanted to see how congruent it is to practitioners' knowledge, which led us to conduct a formative evaluation and multiple design iterations to refine our framework. We recruited a total of 19 policy communicators, and each interview session consisted of 2 distinct sections before and after introducing our framework. Before introducing the framework, we focused on understanding their current practices and challenges in policy communication. After introducing the framework, we asked them to apply their example and reflect on their experiences using the framework. After the formative evaluation, we did a before and after comparison to help us evaluate whether our framework was congruent with practitioners' knowledge. Before introducing the framework, we found that participants' examples covered all of the categories, but one reasoning misleader category, inadequately representing uncertainty. After introducing the framework, there were notably more discussions around all categories and more examples from participants. And none of the participants mentioned an obviously missing category, which suggests that the framework covered the categories important in practice. However, even though there was a general consistency with the policymaking stages, there were more instances of non-perfect correspondence with our participants' examples. For instance, P12 mentioned that they do all of these stages at different time points. We noted participants' feedback throughout the interviews, and starting with the preliminary V-framer, we iteratively refined the design of the framework in between sets of participants to incorporate their feedback and ultimately reached our final framework. You can find more details on this iterative design process in our paper. But now with this final framework, a natural question that follows is, how might V-framer be integrated into existing workflows? Our participants offered us some interesting insights on how this framework might be useful. For instance, many participants commented on the potential of it as a checklist. For example, P1 mentioned that the framework has a lot of the key things that we need to take a look at before anything goes out. P4 said that, I think once I read it, a lot of things clicked in my mind of challenges we address. I don't think I oftentimes think about all the challenges at once. Some comments also suggested this framework could be a brainstorming tool and can be useful in the first iteration of making a visual. There were also comments that supported the potential integration of it as an educational tool, such as for younger analysts who are joining the team and might be taking over work. P14 mentioned that it's just like a reminder for best practice. Starting with these potential integrations of eFramer, future work can investigate ways of maximizing the framework's utility. Some interesting directions might include deploying it to document actual usage over time, which could lead to alternative insights for further refinements and expansions of the framework. Thank you.